Alright, this video I am going to talk to you about some different functions that we call parent functions. So I've created a chart, and what I'm going to do is show you what the chart looks like. I would recommend pausing the video to get your paper set up, and then you can continue the video once you have your chart ready to go. So I made 4 columns in my chart. The 2 on the right are a little bit bigger on purpose. And then I have 6 sections going down. So I have my title up here, and then I've got 6 sections going down. And so if I go out, so you can kind of see, this is basically taking up the entire page. So I've got, again, my row up here with the titles of each one, and then I've got 6 sections below, and then 4 columns across. So my recommendation would be to pause the video so that you can get your paper set up, and then once it's set up you can continue. Alright, the first function, and this is not a new one, you've been talking about this before, but I want to start with linear functions. And we know already that a linear function is going to make a line on the graph. So a graph of a linear function is any non-vertical straight line. So we could have something like that. We could have a horizontal line. We could have a diagonal line with negative slope. So when we talk about linear functions, we're talking about non-vertical lines. All right, domain and range. So domain, as you remember, is referring to the x values of our function. And when we look, a line is going to go on forever in both directions. So that means it's going to continue forever to the left, and it's going to continue forever to the right. So our domain is from negative infinity to infinity. And then this is one where the range is going to be exactly the same. So this line is going to continue to go up. That line is going to continue to go down. Now, if you have a horizontal line, that is different, but for the majority of our lines, anything that's not horizontal is going to have a domain and range that is all real numbers. So for characteristics, I think it's important to mention that this follows the equation y equals mx plus b. We have also talked about arithmetic sequences. So our arithmetic sequence follows the same form. This one involves slope, which we also know is a common difference. Uh-oh, I'm going to run out of room there. So when we think about a linear function, we think about a line. And although it can be different equations, those are our main ones that we think about for a linear function. Just to throw another one in is we can have x and y on the same side. So that one right there is standard form. So that covers our linear functions. So our next function is quadratic. So quadratic functions. So this might seem odd, but in some ways it makes sense at the same time. But a quadratic function looks like this, or it could be one thinner and going down. So quadratic function makes a U shape on the graph, and we call that a parabola. So I'm actually going to jump over here for a second. And when we graph a quadratic function, it makes a parabola. All right, let's talk domain and range. So I didn't do a great job drawing this, but these parabolas are going to continue to go out and out and out, and they're going to get wider and wider as they continue on. So the domain of a quadratic function is always going to be all real numbers. Now, the range is going to not be all real numbers. This is only going on forever in one direction. So remember, we always go low to high. So for this one right here, this is going to be our low point. So it's going to go bracket. But it's going to continue forever going up. The other thing that could happen is if it's looking like this, it's going to come from negative infinity, and it's going to go up to that endpoint and then stop. All right, quadratics look like an x squared. So it can be anything with an x squared as the variable. Now, there are other forms of our quadratic, again, but just like the linear, but we're going to stick with, if you see an x squared, you know that's quadratic, and the shape of the graph is going to look like that. All right. Next up is our exponential function. So exponential function. And as you might have guessed, this is going to involve an exponent. On a graph, an exponential function makes a curve. And it's a curve that flattens out. So it's going to come down and flatten. So it's going to not actually ever go straight, but it's going to flatten out here while it continues to go up that direction. It could also look something like where it comes up and flattens out that way. So it can look, either one of those would be examples of exponential functions. So again, our domain is going to be all real numbers, because this is going to continue to go to the left and it's going to continue to go out to the right. Now, the range on an exponential function is more similar to the quadratic, but this time it doesn't ever actually stop and hit anything. So we would say, like for this one, it's going to maybe go down to, let's just say it's going down to 0, but then it's going to go up to infinity. Or another thing that it could do is start down here at negative infinity, and maybe it comes up all the way to 0, but it doesn't actually ever stop and hit it. So you probably guessed that, well, first this is just called a curve, but our equation is going to look like a number to the x. So I'm going to say b to the x. So it could be like 2 to the x, or it could be 3 to the x, or it could even be 1/2 to the x. But if the x is the exponent, that's when it's exponential. All right, next up, we are going to talk about the absolute value graph. So, absolute value function Now, this one is kind of a combination of the first two. When we have an absolute value function, it makes a v. So it makes a perfect v. And it doesn't have to be centered at the origin, just the parent one is, but it could also go down instead of up. So this one is going to be more like the quadratic domain and range. So the domain is going to be negative infinity to infinity, because it's just going to continue going out, 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 either direction. But the range is going to be more like the quadratic, where it actually hits an exact point. So you're going to have a bracket with infinity, or you could have negative infinity with a bracket. And again, this would be a number right in here that just depends on where the location is. So an absolute value graph is more of a V-shaped. So I'm going to say V-shaped. And the equation would look something like that, where we have the absolute value bars with the x. All right, moving right along. The next one that we're going to look at is a square root function. So a square root function is kind of like half of a parabola. So the parent one starts right here at the origin, and it just goes up and over. So it can go different ways. It could go kind of under instead of up and over, but it has a starting point, but then it's going to continue in one direction. So for the domain is going to be more of a starting point, but then it goes on forever. Or it might come from the negative side and then stop. It could also do that. All right, for the range is going to be almost exactly the same as the domain. So you're going to have a starting point, and then it's going to continue up forever. Or maybe you have a starting point, and it's going to continue getting smaller forever. All right, so a square root equation is exactly what you would think. It's going to be the square root of x. All right, last one. So we're almost finished. So the last one is the cube root function. And I'm not sure if you have even been exposed to cube roots yet, but you probably can guess that where a square root would go with squaring a number, the cube root goes with cubing a number, or taking the, like, to the third power. So for one thing, our equation is going to be this, look like that, because the cube root of a function has a 3 right there, and I know it's not showing up very good. I don't have a super dark purple here, but so this is a 3 right here. Now, when we do a square root, we don't really put the 2 in there. It's just understood that the 2 would go in there. All right, now on a graph, it's going to look something, like that. So it's going to kind of curl up. It does go through the center, and then it kind of rolls a little bit. So it's similar to the square root function, except it's almost more of like an S shape in a way. So this domain and range goes all the way back to linear. So for the domain, it's going to go on forever from left to right. So it's going to go forever to the left and forever to the right. And then the same thing is going to happen with the range. It's going to go down forever on this side, and it's going to continue to go up forever on the right side. All right, so those are the parent functions that we're going to look at. And what we're going to be doing is just identifying which one it is based on whether you look at the graph or you look at the equation, and then we're still working with domain and range. But that just gives you an idea of the 6 parent graphs that we are going to be working with.